Hello everyone, I am Dr. Regioselectivity. I welcome you in my YouTube channel. Today in this video, I am going to talk about ambident nucleophiles, regioselectivity. In last video, I already discussed about ambident nucleophile. So, I would suggest if you are interested to learn clearly about ambident nucleophile, please go through my previous video. Then this topic will be more clear to you. So let us start learning of regioselectivity in ambident nucleophile. So nucleophiles which can attack the substrate through two or more atoms to give different product are called ambident nucleophile. When a reaction is capable of giving two or more structural isomers like ROCN or RNCO, but actually gives only one, the reaction is called regioselective reactions, and this phenomenon is known as regioselectivity. The following are some important ambident nucleophiles. Ion derived from malonic ester, beta keto ester, beta diketones, etc. are resonance hybrids. So you can see here C minus, here O minus, here another O minus. So this is ambident nucleophile and can attack through their carbon atom C alkylations here or through their oxygen atom O alkylations here to give three products in case of unsymmetrical ions. Now next, compound of the type CH3CO, CH2CO can form a dianion on treatment with a strong base. If you have a compound like this, you are using 2 moles of base, there is 2 anion, CH2 minus here and CH minus here. So such ambident nucleophiles can attack through two carbon atoms beside the attack through oxygens. In such cases, the attack is always through the more basic nucleophile carbon. Now, the negative charge of CH, here carbon ion, is delocalized on two CO groups, whereas that of the CH2 minus on only one CO group. Consequently, CH minus is less basic than CH2 minus, and the attack takes place through CH2 minus. Thus, such compounds, example ethyl acetoacetate, can be regioselectively alkylated at either the methyl or methylene groups. So you can see the reactions. You have this ethyl acetoacetate, 1 mole of base and 2 mole of base. You have more stable form first and then alkyl group attack, and this is the product. You have less stable, more reactive, more stable, less reactive, and then you have this product, and then H plus you will get this product. So now third, the Cn minus ion can give RNC or RCN. RCN means nitrile and RNC means isocyanide. So here you can see this is the benzene, this is alkyl, the O minus, react with Rx forming this product, one this product and one this product. These two are C alkylated and these O are O alkylations. Now the next, 4-nitrite ion NO2 minus can give RONO, nitrite ester or RNO2 nitro compound. Now next, phenoxide ion, which are analogous to the enolate ions, can undergo C alkylation or O alkylation. Now my friends, factor governing the regioselectivity in ambident nucleophile. You know, exceptions are there, always there. The following general rules are useful in predicting which atom of an ambident nucleophile would attack the substrate under the given conditions. First, as the character of a given reaction changes from SN1 to SN2 like, An ambident nucleophile is more likely to attack through its less electronegative atom. And this is because in SN1 nucleophile attacks a harder carbon and SN2 is a softer. The more electronegative atom is harder and less one is softer. And the hard and soft interaction is preferred according to the HSAB rule, Hassab principle, hard soft acid base theory. Thus, the changing from SN1 to SN2 condition should favor carbon attack by the CN, nitrogen attack by NO2, and carbon attack by enolate or phenoxide ion. The second important point, if the positive counterion of negatively charged nucleophile helps in removing the leaving group, for example, silver plus, Hg2 plus, Hg2 plus, rather than sodium plus or potassium plus, then the transition state is more SN1 like and the attack through a more electronegative atom is favored. For example, alkyl halide on treatment with sodium cyanide generally gives mostly RNC, but the use of silver cyanide increased the yield of RNC. You can see here RBR, silver cyanide, it gives precipitate of silver bromide and RNC. The third important point, an increase in the electron withdrawing character of X in Rx gives the carbon atom a higher positive charge. Due to this making it harder acid. Thus, such changes increase in the extent of attack through the more electronegative atom. For example, oxygen or carbon ratio increases in the order Ri less than Rbr less than Rcl, Rot. For a series of alkylation of the sodium salt is here, ethyl acetyl acetones. Now, next important point is, many cases solvent affect the position of attack. The freer the nucleophile, the more likely it is to attack through its more electronegative atom. But more this atom is either likely solvated or close to the positive counterion. The more likely is attack through the less electronegative atom. The protic solvent, the more electronegative atom is better solvated by hydrogen bonding than the less electronegative atom in polar aprotic solvent, neither atoms. So you can see in this example, here you have the sodium salt react with this. You have dimethyl sulfoxide and you have another solvent. So 95% O and 85% Cl conditions. So the nucleophile is greater solvated, but the positive counterion is more effectively solvated. Thus, in polar aprotic solvent, the more electronegative end of the nucleophile is freer from the entanglement from both the solvent and cation, so that a change from a protic to a polar protic solvent often increases the extent of attack through a more electronegative atom. Now, changing the cation from lithium plus to sodium plus to potassium plus in nonpolar solvent favors O alkylation. Remember, favor O alkylation over C alkylation, because K plus leaves the nucleophile much freer than lithium plus. My friends, these all topics is very important. The use of crown ether. Just imagine the picture of crown ether. It is interesting to note that alkylation of the enolate anion or ion of cyclohexanone in gas phase, whereas nucleophile is completely free, undergoes only O alkylations and no C alkylation. Then the last factor, which is the fixed factor, steric effect. Steric effect is also play very important role. So steric effects can also govern the regioselectivity. Steric factor. So my friend, I hope this video or this type of video will be beneficial for you. If you like this type of video, then subscribe my channel, share it in your friend circle. Thanks for watching.